Hi everybody, I'm going to be doing a quick review with you for heterogeneous and homogeneous mixtures. You may have heard of them referred to as homogeneous mixtures. You have probably heard the terms heterozygous and homozygous, but when we're talking about heterogeneous or homogeneous mixtures, we're talking about mixtures of compounds or particles or substances. So as we go into this, first thing we need to look at, remember, a mixture is going to be composed of two or more substances. Remember, that can be elements, or it can be compounds, or it can be elements and compounds. So remember when you did some of the particles where we had to look, is it a black dot and a white dot? Is it just two white dots? Is it a diatomic molecule? That's what we're talking about. These are possibly mixtures. Remember, a mixture is going to be physically combined. It is not going to be chemically combined. Remember, something that's chemically combined would be water. Water is chemically combined. I can't get my tweezers out and pull the hydrogen away from the oxygen. There has to be a chemical reaction that takes place to get hydrogen and oxygen to separate. So we're going to be talking about things that are physically bonded. Remember when you did the FOSS activity, you could take things apart. We did sifting, we did a magnet, we did evaporation. These were all things we could do to physically pull mixtures apart. This is going to be chemically combined, a compound. We're going to be looking at something like NaCl plus H2O. That would be something we could do evaporation and get that mixture apart. Oops. So what exactly is a homogeneous mixture? These are going to be mixtures that you can't see the different parts that make it up. They're going to be fairly evenly distributed. Words you're going to hear with homogeneous mixtures are going to be uniform in appearance, fixed composition. These are going to be ones that you look at and you don't really say, oh look, I can see this part of it and this part of it. Typically they're going to be the same two states of matter mixed together. You can see them in other ways, but for this, we are going to be looking at it and it is uniformly distributed. Some of the things that you are used to, most of the things you're used to, are going to be like that. When we take this, when we take something that is a homogeneous mixture and we look at it, it looks very uniformly distributed. The example that I used, remember, was that if I took a sample from the front of the room, if I filled the room with salt water, and I had a sample from the front and a sample from the back and a sample from the side, I would have water and salt in every single sample that I took. Some of the ones that you might be used to, vinegar is one, salt water, cola, the air you breathe. Remember, you don't walk down the hallway and go, oh, I just hit a big old patch that didn't have any oxygen in it. Whew, that was scary. The air we breathe is a homogeneous mixture. It's very uniformly distributed. We don't see the differences. So heterogeneous is going to be the complete opposite. These are going to be mixtures where we can see both pieces together. We can see them and their distribution within the mixture itself. You are going to be able to look at it and say, oh, a trail mix. I see a peanut, and I see a raisin, and I see an M&M. If I were to fill the room up with a salad, remember that was the example I gave in class. If I filled the room with a salad and I took a sample from the front, the back, and the side, I very well may end up with lettuce and tomato from up front. I may end up with an onion from the back, and I may end up with a crouton from the side. I wouldn't have an even distribution of substances within that mixture. And that is what a heterogeneous mixture is. A mixture that most likely you are going to be able to look at it and say, Well, I could take a magnet and pull the iron filings out of the sand. Very easy to see, very easy to separate. Homogeneous mixtures are a little more difficult to separate, but they can still be separated. Some examples. Fruit salad. You can easily say, oh, I see a strawberry, I see a grape, I see a blueberry. You could easily pick those out. That's not hard. It doesn't look like one uniform substance. Sand on the beach. Yes, it looks all the same from a distance, but if you pick it up, you're going to be able to see the little pieces individually. You can see lighter colored minerals, you can see darker colored minerals. That just is a homogeneous mixture. If you really wanted to sit there and pull it apart with tweezers, you probably could. It would take you a while, but you could do it. Milk and cereal. It's a mixture. Yes, it's in two different states, but it's a mixture. If you ate all the cereal out of there and you just had the milk left, milk is technically a colloid, but it is a homogeneous mixture because of the particles that make it up. Remember, homogeneous mixtures are referred to as solutions. Hopefully you've seen the molecular level before. If we go all the way down, remember the flow chart where you have matter that becomes pure substances and mixtures. Pure substances can be broken down into elements and compounds. So remember, compounds are chemically combined. Elements can be the diatomic molecule, or they can just be an element just floating around. These are the two we're concerned about, homogeneous and heterogeneous. If you look at the homogeneous, you see sort of like a uniform blend. If you look at it and see that you've got some here and they're over here and it's all blended together, it's going to most likely be a homogeneous mixture. Heterogeneous, you're going to see chunks. It's kind of chunky. You're going to have pieces that you could easily identify as like, oh, there are all the purple guys. I could pick those out. Whereas here, it would be a lot more difficult. Giant clumps of them would be like the strawberry in the fruit salad. And this would be like the grape. Or maybe we want to use the cereal. Here's a piece of the cereal, here's the milk. Whereas this would be like the cola, or the pop, or the soda, or whatever you want to call it. I think I covered all my bases. The Coke. Yeah, I think I got them all. But this is more evenly distributed where you have giant chunks in the other side. Does that make sense? Good. And I believe that's our last one. So hopefully this helps. If you have any questions, feel free to ask your science teacher. You can ask me, whatever you need to do. Good luck. If you need some extra help, you can always go to one of our websites.